In this program, you will learn the standard procedures for setting your Gmaw equipment to produce flat welds using both short circuit and spray transfer modes. The most basic requirement for a strong weld is proper and thorough cleaning of the base metal, no matter what type you intend to weld. For demonstration purposes, the base metal that we shall use throughout this program is mild steel. Thorough cleaning is best effected using an angle grinder, although a belt sander may also be used where applicable. All traces of rust, mill scale and other substances must be removed from the surfaces within the weld zone. Do not overlook the edge of the metal, which of course forms the root face on joints. Aluminium and stainless steel should be treated in similar fashion, but care must be taken to ensure that you use the correct type of grinding wheel rated for stainless steel. Never use a steel-rated wheel, especially upon aluminium. It must be kept in mind that your metal welding bench often forms part of the welding circuit. Your bench top must be clean and free of rust, paint, oil, or any other substances that will cause an electrical resistance. The work lead must always be connected to a bright and clean portion of your bench. When it is necessary to remove oil and grease from the base metal, or from your workbench, then use acetone. This is especially important when preparing stainless steel and aluminium. Do not use petrol, paraffin, or paint thinners for cleaning purposes. Shielding gas adjustments we need make concern the gas delivery flow rate and post-flow. Shut the flow control valve before opening the delivery valve. Observe the standard safety precautions when opening a delivery valve. Next, ensure that there is adequate gas in the cylinder by observing the pressure gauge. Switch on the power source in order to activate the control circuits. Where applicable, set the trigger control to the 2T position. Turn the post-flow control setting to maximum, which, typically, will provide around 30 seconds of gas flow. Next, press the purge button, or operate the gun trigger momentarily in order to activate the gas control valve within the welding machine. The flow control valve is now slowly opened, and the indicator ball will rise inside the sight tube. Observe the top of the ball at eye level and compare this position to the graduated scale on the tube. Adjust the flow by manipulating the control valve until the desired flow rate has been achieved. When using an argon mix gas, the flow rate is normally set between 12 and 15 liters per minute. Next, the post-flow setting can be adjusted. As a guide, set the control to around the halfway point when welding mild steel, and to maximum for aluminium and for stainless steel. Prior to operating the welding gun, there is one setting that needs to be made, namely the electrode protrusion or stick-out. Stick-out is the amount of electrode wire that should protrude from the contact tip. This distance is important as it provides the correct conditions in which the electrode wire is preheated, and it also produces the desired envelope of shielding gas over the weld pool. When using short-circuit transfer mode, the electrode should stick out beyond the nozzle by approximately 8 to 13 millimeters. For spray transfer mode, the stick-out should be twice this distance, that is, between 16 and 26 millimeters. In practice, the stick-out is set by operating the trigger, or the wire jog. Then, using your cutting pliers, snip the wire to leave the desired amount of protrusion. Take care when cutting wire. Always point the nozzle away from your body, and away from others in the area to prevent injury from the piece that flies off. With the stick-out set as required, the gun is ready for action. Arrange the welding cable so that it is free of sharp bends, which will ensure that the wire feeds smoothly to the contact tip. Hold the gun in a relaxed grip, making sure that the trigger is in easy reach. For flat position welding, you will find that controlling the gun will be made easier using the two-hand method as demonstrated. Most welds are made with the gun held at an angle of between 20 and 25 degrees off vertical. Travel may be made in the forehand direction or in the backhand direction. Deeper weld penetration is achieved using the backhand direction. Whichever direction you decide to use, keep in mind that the distance between the nozzle and the work must be maintained as steadily as you can, which is why we recommend the two-handed support as earlier mentioned. It is suggested that you now set the required stick out and then, with your machine switched off, practice holding and moving the weld gun over the surface of practice plates.